this episode, we are stepping back from individual alerts and incidents so we can understand the larger environment that makes modern defensive work possible in the first place. A modern security operations center, SOC, is not just a room with big screens, blinking dashboards, and analysts watching endless streams of warnings. It is a connected operational system made up of data sources, platforms, workflows, storage, access controls, and people who need all of those parts to work together well enough to produce timely understanding. For a beginner, this topic matters because many security problems feel confusing only when the surrounding infrastructure remains invisible. Once you understand the major pieces that feed a SOC, the paths information takes through those pieces, and the reasons certain tools exist, the work of monitoring and analysis starts feeling much more logical. You stop imagining the SOC as a mysterious place where alerts simply appear, and you start seeing it as an environment built to collect evidence, organize it, compare it, and help defenders decide what deserves action. When people hear the word infrastructure, they often think only about hardware, but SOC infrastructure is much broader than a few servers or network devices sitting in a rack. In this setting, infrastructure means the full support system that allows security data to be generated, transported, stored, searched, correlated, and acted on in a consistent way. That includes endpoints, servers, cloud resources, identity systems, networking paths, centralized platforms, storage layers, automation tools, case management processes, and the controls that protect all of those parts from misuse. The key idea is that analysts do not defend an organization by staring directly at the raw environment all day. They depend on infrastructure that brings important signals together in a form humans and tools can actually use. If that infrastructure is weak, fragmented, or poorly governed, analysts may still work hard and yet remain blind to important activity. A strong SOC, therefore, depends not only on skilled people, but also on an operational backbone that turns scattered technical behavior into usable security visibility. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. One of the most important pieces of that backbone is the set of systems producing the data in the first place. Workstations, laptops, servers, mobile devices, network appliances, cloud workloads, and applications all create evidence about what they are doing, and a SOC depends on those systems being visible enough to support monitoring. An operating system, OS, records user logins, process starts, service changes, access events, and many other clues that help analysts understand endpoint behavior. Applications generate their own records about transactions, requests, failures, and user actions, while infrastructure services create evidence tied to authentication, configuration, connectivity, and administrative change. This means a SOC does not begin in the SOC itself. It begins at the edge of the environment where activity happens. If important systems are missing from visibility, if shadow assets exist outside approved monitoring, or if key applications do not generate useful records, the SOC inherits blind spots before the first alert is ever raised. Coverage, therefore, is not just a technical detail. It is one of the first infrastructure questions that shapes how trustworthy the entire defensive picture will be. Networking is another core infrastructure concept because the SOC lives on movement as much as it lives on static system state. Systems communicate constantly, and those communication paths create both opportunity and risk for defenders. Normal traffic patterns help explain what a system is supposed to be doing, while unusual traffic patterns often become some of the earliest signs that something is wrong. Modern SOC infrastructure depends on visibility into internal communication, external communication, remote access, cloud paths, and the boundaries between trusted and less trusted parts of the environment. Segmentation matters here because the way networks are separated influences both security and observability. A flat environment where everything can talk to everything else is harder to defend and often harder to investigate because suspicious activity blends into a larger mass of poorly controlled movement. A better designed environment creates clearer boundaries, which helps both protection and monitoring. Analysts benefit when they can understand which connections are expected, which are unusual, and which paths would create the most concern if abused by a compromised system or account. Identity is equally important because much of modern SOC infrastructure is built around knowing who or what is trying to access a resource and whether that action should be happening. Identity and Access Management (IAM) systems provide records about logins, failed attempts, privilege changes, group membership, service account use, and access decisions that may be among the most important signals in the whole environment. This matters because many incidents are really identity stories before they are anything else. A suspicious sign-in, an unusual token use, an unexpected privilege assignment, or access from a strange location may become the first reliable indicator that an account is being misused. Modern infrastructure also depends heavily on multi-factor authentication, MFA, centralized identity providers, and federated access across cloud and internal environments, which means identity systems often sit near the center of both security control and security visibility. For a beginner, one of the most useful mental shifts is realizing that the SOC is not only watching machines. It is also watching trust decisions, and many of those decisions flow through identity infrastructure. At the center of many SOC environments sits some form of centralized analysis platform, and the most familiar high-level example is a security information and event management (SIEM) system. A SIM is not magic, and it does not create insight by itself, but it provides a place where logs and events from many sources can be collected, normalized, stored, searched, and correlated. That matters because defenders need a way to connect activity across endpoints, applications, network devices, cloud services, and identity systems without manually hopping through each source in isolation. Good SIM infrastructure helps analysts search timelines, compare activity between systems, and build detections that trigger when several weaker signals combine into a more convincing pattern. It also supports investigations by preserving records in a place where they can be reviewed after the moment has passed. A beginner should think of the SIM not as the whole SOC, but as one of its main organizing layers. It helps transform scattered evidence into a shared operational view, which is essential when the environment becomes large, fast-moving, and too complex for manual tracking alone. Endpoint-focused infrastructure adds another major layer because central log collection is useful, but it often does not tell the full story of what a device is doing locally. Endpoint detection and response, EDR, platforms help fill that gap by watching process execution, file activity, registry or configuration change, persistence attempts, script behavior, and network activity from the endpoint perspective itself. This is valuable because many important security questions begin at the device level. Which process started this action? Which account launched it? What files changed? What parent process led to this child process? And whether the behavior fits a known malicious pattern are all questions better answered with stronger endpoint visibility. Some organizations also extend this idea through extended detection and response, XDR, which tries to bring together endpoint, identity, network, email, and cloud signals into a more unified investigative picture. The important beginner lesson is that SOC infrastructure works best when it combines broad centralized visibility with deeper local visibility. One gives scope, and the other gives detail, and strong analysis often depends on moving between those two levels of understanding. Case management and workflow infrastructure matter just as much as telemetry platforms, because a SOC is not only a place where information is observed, it is also a place where work is tracked, handed off, escalated, documented, and closed. Once an alert becomes meaningful, the team needs a reliable way to create a case, record evidence, assign ownership, track actions, and preserve the logic behind decisions. This is why ticketing systems, case platforms, and evidence nodes are part of SOC infrastructure rather than administrative afterthoughts. Without them, incidents become harder to coordinate, easier to forget, and more vulnerable to inconsistency between analysts or shifts. Some environments also use security orchestration, automation, and response, SOAR, platforms to automate repetitive steps, enrich alerts, open cases, and support faster response paths for known situations. The key point is that infrastructure is not just about gathering signals. It is also about making security work manageable, repeatable, and visible across the team. Good workflow design helps prevent the SOC from becoming a collection of private analyst judgments with no lasting record or shared operational memory. Storage, retention, and search design are also essential concepts because modern SOCs produce and consume enormous volumes of data. Not all records can live forever in the fastest and most expensive storage, but not all records can be discarded quickly either. Analysts may need to look back days, weeks, or months depending on when suspicious behavior is first noticed and how long an attacker may have remained in the environment before detection. This means SOC infrastructure needs thoughtful approaches to how long data is kept, how searchable it remains, and when it moves from high-speed storage into longer-term archives. It also means timestamps, consistency, and indexing matter far more than beginners often expect. Data that exists but cannot be searched efficiently may be nearly as frustrating as data that was never collected at all. Strong infrastructure therefore treats storage as an operational design problem, not just a capacity problem. The goal is to preserve enough usable history to support defense, investigations, and trend awareness without creating a system so costly or disorganized that the team struggles to extract value from the data it worked so hard to collect. Reliability and resilience are just as important inside the SOC as they are anywhere else in the organization. If logging breaks silently, if ingestion pipelines fail, if the core monitoring platform becomes unavailable, or if a critical collector goes down during an incident, the security team can lose visibility at exactly the moment it most needs clarity. That is why mature SOC infrastructure includes ideas such as redundancy, buffering, failover, health monitoring, and backup plans for essential components. The purpose is not to create luxury. It is to prevent a single point of failure from turning into a blind spot across the defensive operation. A beginner should understand that a monitoring system that is unreliable is not just inconvenient. It is itself a security risk because defenders may be making decisions based on incomplete information without realizing it. Strong SOC infrastructure, therefore, includes monitoring of the monitoring systems. Teams need to know whether data is flowing, whether collectors are healthy, whether time alignment is intact, and whether critical sources remain present in the places analysts expect them to be. Another vital concept is that SOC infrastructure must be protected like a high-value asset because it often contains enormous amounts of sensitive information and powerful visibility into the environment. The platforms analysts use may hold logs, user activity records, system details, cloud events, investigative notes, and credentials or connections that enable deeper access. If an attacker reaches into that infrastructure, the damage can be severe. They may learn how the organization monitors activity, erase or alter evidence, disable detections, harvest additional information, or use trusted security platforms as stepping stones for further compromise. That is why access control, separation of duties, administrative logging, hardening, and careful privilege management matter so much inside the SOC itself. The team defending the environment cannot assume its own tools are somehow outside normal security concerns. In many ways, the opposite is true. The more central and trusted the infrastructure becomes, the more carefully it must be protected because compromise there affects both present detection and future understanding of what happened. Modern SOCs also operate in a much more distributed world than many beginners first imagine. The environment is no longer only about internal servers and office workstations connected to one corporate network. It often includes remote employees, cloud applications, software services outside direct company ownership, mobile devices, third-party platforms, and workloads that appear and disappear dynamically. This changes infrastructure design because visibility must now reach across boundaries that are less centralized and sometimes less stable than traditional environments. Application Programming Interface, API, connections, cloud-native logging, identity-driven access records, and shared telemetry from external platforms become part of the operational picture. The SOC therefore becomes less like a fixed room watching one building and more like a distributed observation function trying to maintain awareness across many connected environments at once. For a beginner, this is an important idea because it explains why modern security monitoring feels so data-centric. The infrastructure is designed to pull perspective from many places, precisely because the environment being defended no longer lives in one simple location. Human workflow sits at the center of all of this, because the best infrastructure in the world is still meant to support people making decisions under pressure. Dashboards, alert queues, enrichment tools, case notes, playbooks, and escalation paths all exist to help analysts turn data into judgment and judgment into action. When infrastructure is built poorly, analysts waste time hopping between tools, re-entering information, chasing missing context, or staring at streams of low-value noise. When it is built well, the right information arrives in a form that matches the work the human needs to do next. That does not mean the SOC becomes effortless. It means the infrastructure reduces avoidable friction so the team can spend more energy on understanding and less on basic operational confusion. One of the biggest misconceptions about modern SOCs is that success is mostly about buying the newest platform. In reality, success usually depends on how well the environment's pieces fit together to support human analysis, communication, and response. By the end of this discussion, the most important thing to carry forward is that modern SOC infrastructure is really the operating foundation of defensive visibility. It includes the systems that generate evidence, the networks that carry it, the identity services that shape trust, the platforms that centralize and enrich it, the workflow tools that organize action, the storage and resilience layers that preserve it, and the controls that protect the whole structure from misuse. Once you see the SOC this way, many security concepts become easier to place. Alerts no longer appear from nowhere. Investigations no longer feel disconnected from architecture, and defensive work starts looking like the coordinated use of a carefully built operational environment. That is exactly why infrastructure concepts matter so much in modern SOCs. They explain how defenders create sight across complex systems, and they remind you that good security analysis is rarely the product of one tool or one smart person alone. It is usually the product of many well-connected parts working together well enough for the right signal to reach the right human at the right time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.